Hi, this is Austin Dennis back with another TryHackMe walkthrough. We're going right now on the Introduction to Cybersecurity Learning path, and today we're on the fourth room in that path, Web Application Security. So we can go ahead and jump right in here to task number one, the introduction. It says every one of us uses different programs on our computers. Generally speaking, programs run on our computers using our computer's processing power and storage. Moreover, to use a program, we need to install it first. What if we can use any program without installation? A web application is like a program that we can use without installation as long as we have a modern standard web browser such as Firefox, Safari, or Chrome. Consequently, instead of installing every program you need, you only need to browse the related page. The following are some examples of web applications. Webmails such as Totonoa, ProtonMail, Outlook, and Gmail. Online office suites such as Microsoft Office 365, Word, Excel, and PowerPoint, Google Drive, Docs, Sheets, and Slides, Zoho Office, Writer, Sheet, and Show. And online shopping such as Amazon.com, AliExpress, and Etsy. Thousands more examples provide a myriad of services. Other examples include online banking, money transfer, weather forecasts, and social media. Basically, anything that you're looking at online, you're on a computer, and right now I'm using a Google Chrome web browser to access TryHackMe. TryHackMe isn't something that I have installed on my computer. None of you are going to have TryHackMe installed on your computer. You're accessing it through the web browsers. Basically, most of the things that you're going to do on your computer, unless you have a lot of things pre-installed on it, are usually going to be done through a web browser. So it's very important for us as cybersecurity professionals to be familiar with these things, understand how they work and all the different things about them, because there's lots of things that are very vulnerable on web applications, such as payment information and things like that, with a lot of people shopping online. These are things that need to be secure, and we understand fully how they all work. So the idea of web application is that it is a program running on a remote server. A server refers to a computer system running continuously to serve the clients. In this case, the server will run a specific type of program that can be accessed by web browsers. Consider an online shopping application. The web application will read the data about the products and their details from a database server. A database is used to store information in an organized way. Examples include information about products, customers, and invoices. A database server is responsible for many functions, including reading, searching, and writing to the database. The online shopping web application might need more than one database to access. For example, a products database. This database contains details about the products, such as name, images, and specifications and price. Customers database. It contains all details related to customers, such as name, address, email, and phone number. Sales database. We expect to see what each customer has purchased and how they paid in this database. We can already see the amount of information stored in any online shopping system. Suppose an attacker manages to exploit or hack the web application and steal the customer's database. In that case, this will lead to a significant loss for the company and its customers. The image below shows searching for an item on an online shopping site. In the simplest version, the search will take 4 steps. Number 1, the user enters an item name or related keywords into the search field. The web browser sends the search keywords to the online shopping application. The web application queries searches the products database for the submitted keywords. The product database returns the search results matching the provided keywords to that web application. And number 4, finally, the web application formats the results as a friendly web page and returns them to the user. And there's a graph and diagram of those things explained here. Don't get intimidated by that. As you go through this and learn more about networking and the way that these things work, it'll make a lot more sense to you if that doesn't make sense there. It says from the user's perspective, they will only access an elegant online shop where all the technical infrastructure is hidden, and this is an example of something that you would see on a regular basis as you're going through and just surfing online. So many companies offer bug bounty programs. A bug bounty program allows the company to offer a reward for anyone who discovers for a security vulnerability weakness in the computer systems. The main condition is that the found vulnerability is within the bug bounty scope and rules. Among others, Google, Microsoft, and Facebook have bug bounty programs. Discovering a bug can earn you a few hundred US to tens of thousands of US, depending on the severity of the vulnerability or the weakness that you discovered. So, It comes to the question for this task. We only have one to answer, and it is, what do you need to access a web application? Now, don't think that this is some advanced, deep thing. If you just scroll all the way back up to the top, you might have missed it and you weren't looking at it at first. But this very first sentence that we have, a web application is like a program that we can use without installation as long as we have a modern standard web browser. In order to access any web application, you need a browser. So we can type that in right there, browser, and that was the correct answer. Moving on to the second one. We're looking at the security risks. This obviously is cybersecurity. We're learning about web applications, but specifically in light of cybersecurity. It says, let's say that you want to buy an item from an online shop. There are certain functions that you would expect to be able to do on this web application. Most straightforwardly, the online order might go as follows. Number 1, you log in at the website. Number 2, you search for the product. Number 3, add the product to the shopping cart. Number 4, specify the shipping address. Number 5, provide payment details. So there's a few main categories of common attacks against web applications. You need to consider this following on related attacks. So with a login at the website, the attacker can try to discover the password by trying many words. The attacker would use a long list of passwords with an automated tool to test them at the login page. This is the reason why when you're logging into a web application, they'll tell you to make a secure password, and using different steps such as not using uppercase and lowercase letters, adding numbers in, adding special characters and symbols. The reason that you want to do those things is because if you're not, your password is at risk for a brute force attack, which is basically when someone will just take a text list of like 1,000 or 10,000 different words, maybe from a dictionary or just common passwords that people use, and try all of them over and over and over and over again. So for example, if your password is something like password or password 123 or any of the different common passwords that are out there, no one has to deliberately know, but they can basically just run passwords over and over and over and over and over again if they have your username, and they'll be able to get into your password like that. But that is completely prevented if you use a very secure password with numbers, special characters, and symbols. Personally, and many other cybersecurity professionals would also recommend that you use a password manager for all of your passwords so that you don't even know what your password is. It's just a big jumbled mess, and the password manager takes care of all of your logins and everything like that for you so that you're not going to be vulnerable to a brute force attack. Search for the product. The attacker can attempt to breach the system by adding specific characters and codes to search term. The attacker's objective is for the target system to return data it should not, or execute a program it should not. So this would be like in your search bar, or if there's a place on the web application that you can input something like a text, it's asking for your name or to write a note or something like that. People can write in script and manipulate the web application and have it return information that it shouldn't do that. And the other thing they would try to do maybe is provide payment details. The attacker would check if the payment details are sent in clear text or using weak encryption. And encryption refers to making the data unreadable without knowing the secret key or password. So encryption is something that basically everybody's using today, especially as we get further in society and security becomes more of a concern. Most of the different messaging apps that you're going to use online are all encrypted, so the text is the only people that can read it are you and the person. Basically, when you're sending data across somewhere, you're sending a message to somebody, it doesn't just magically pop onto their phone. It has to do multiple different hops through different routers and things like that. And later on, we'll learn more about these things that I'm talking about. But basically, encryption is making it so if I were to send a text message to you saying hello, nobody else in between at any of these routers or anything like that, if they would intercept that information, would be able to read the clear message that I sent, which is just the word hello. But if it's sending clear text, at any point that message can be intercepted and it can be read. Now obviously me saying hello to somebody isn't a major vulnerability or something that would be concerned about, but when you're dealing with websites that are processing payment information, credit card numbers, social security numbers maybe for a government website, it's very important for these details to be encrypted and very a lot of attention paid to the security of it. So it says we cannot cover everything, but we will present a few formal categories from the OWASP top 10. Don't worry if these techniques sound alien to you. TryHackMe walks you through each vulnerability. So Identification authentication failure. So this refers to the ability to identify a user uniquely. In contrast, authentication refers to the ability to prove that the user is whom it claims to be. The online shop must confirm the user's identity and authenticate them before they can use the system. However, this step is prone to different types of weaknesses. Example of these would be the attacker able to use brute force, like I explained earlier, allowing them to choose a weak password, which makes you vulnerable to a brute force, or storing all the user's passwords in plain text. So if the hacker is able to access the place in the web application that they store all of the passwords and they're not encrypted, you don't want them to be able to notice this. So basically, if I'm a hacker, it would be very bad if I was able to access this right here and see all of the passwords of these individuals. Broken access control. Access control ensures that each user can only access files, documents, images, etc. related to their role or work. For example, you don't want someone in the marketing department to access the finance department's documents. Example vulnerabilities related to access control include failing to apply the principle of least privilege and giving users more access permissions than they need. For example, an online customer should be able to review the price of items, but they should not be able to change them. Being able to view or modify someone else's account by using its unique identifier. For example, you don't want one bank client to be able to view the transactions of another client. Being able to browse pages that require authentication, logging in as an unauthenticated user. For example, we cannot let anyone view the webmail before logging in. Another one of these would be injection. So an injection attack refers to a vulnerability in the web application where the user can insert malicious code as part of the input. One cause of this vulnerability is the lack of proper validation and sanitization of the user's input. So this was one of the things I was talking about earlier about inserting code and making the web application do it, whether it's somewhere where your name is or a note that you can leave behind. It's important for web applications to have certain characters filtered out that basically are used specifically to create code. You don't want people to be able to just type code into those things, and there's ways to filter them out, and you'll learn about all that later, and you'll also learn how to exploit those things later to learn both sides of the defense there. So cryptographic failures, this category refers to the failures related to cryptography. Cryptography focuses on the process of encryption and decryption of data. Encryption scrambles clear text into ciphertext, which should be gibberish to anyone who does not have the secret key to decrypt it. In other words, encryption ensures that no one can read the data without knowing the secret key. Decryption converts the ciphertext back to the original clear text using the secret key. Examples of cryptographic failures include sending sensitive data in clear text, for example, using HTTP instead of HTTPS. HTTP is the protocol used to access the web, while HTTPS is the secure version of HTTP. Others can read everything you send over HTTP, but not HTTPS. Relying on a weak cryptographic algorithm, one old cryptographic algorithm is to shift each letter by one. For example, TryHackMe becomes US IBDLNF. This cryptographic algorithm is trivial to break. All you have to do is literally just shift every letter in their bag and it immediately spells out TryHackMe. So using default or weak keys for cryptographic functions, it won't be challenging to break the encryption that used 1, 2, 3, 4 as the secret key. So don't worry if these techniques look challenging or sophisticated at first. TryHackMe has in-depth rooms to help you understand and experiment with the various attacks against web applications. So now that we are down to the questions and we covered some of those vulnerabilities, let's answer them. So first question. You discovered that the login page allows an unlimited number of login attempts without trying to slow down the user or lock the account. What is the category of these of this security risk? So what we're doing here is this is basically the middle of a brute force attack, or it very, very vulnerable to a brute force attack. If you noticed, whether you have like your cell phone or you're using a computer trying to log into a Google account or something like that, after a while, in so many failed attempts, the phone will slowly lock you out to where you can't just continuously try to log in over and over and over and over again, which makes it so that somebody trying to perform a brute force dictionary type of attack, even if you have a weak password, that leaves you vulnerable to something like that. But if the person doesn't have an unlimited attempt to log into the account over and over and over again, that would never even be it. But when we're talking about what the vulnerability of this is, we are looking at an identification and authentication failure. If I can copy that, I'd be able to get it on there a lot faster. But that specific issue is an identification and authentication failure. The next one, you notice that the username and password are sent in clear text without encryption. What is the category of this security risk? So this would be a cryptographic failure. That's the last thing that we just looked at. Like I gave the example earlier about sending a text message to you, whoever's watching the video, and just saying the word hello. We should not be able to get in the middle of all those hops when we're going through the routers to get to you to see that message and be able to read whatever I said. Encryption is very important. We don't ever want to send anything over the internet in the clear. Excuse me. So for the last one, we've got a task where we're going to actually look at a practical example of web application security. So this task will investigate a vulnerable website that uses insecure direct object references. IDOR falls under the category of broken access control. Broken access control means that an attacker can access information or perform actions not intended for them. Consider the case where the web server receives user-supplied input to retrieve objects, files, data, or documents, and that they are numbered sequentially. Let's say that the user has permission to access a photo named image 1003. We might guess that there are also image 1002 and image 1004. However, the web application should not provide us with that image even if we figure out its name. In general, an IDOR vulnerability can occur if too much trust has been placed on that input data. In other words, the web application does not validate whether the user has permission to access the requested object. Just providing the correct URL for a user or product does not necessarily mean the user should be able to access that URL. For instance, consider the product page, https store TryHackMe THM products product ID 52. We can expect this URL to provide details about the product number 52. In the database, items would be assigned numbers sequentially. The attacker would try other numbers such as 51 or 53 instead of 52, and this might reveal other retired or unreleased products if the web application is vulnerable. Let's consider a more critical example. The URL https store TryHackMe THM customers user ID and ID 16 would return the user with ID 16. Again, we expect the users to have sequential ID numbers. The attacker would try other numbers and possibly access other users' accounts. This vulnerability might work with sequential files. For instance, if the attacker sees 007.txt, the attacker might try other numbers such as 001.txt, 006.txt, and 008.txt. Similarly, if you were to change the ID to numbers, if you were to change ID number 16 and ID number 17 was another user, by changing the ID to 17, you could see sensitive data that belongs to another user. Likewise, they can change the ID to 16 and see sensitive data that belongs to you. Of course, we assume here that the system is vulnerable to IDOR, which is what we're talking about here. So let's see this in action. If we click the View Site button, you will see a page showing an inventory management system. If you click on the Planned Shipments tab, which is right over here, you will discover that an attacker has managed to mix things up as part of sabotage the plans. Notice how they send the wrong tires to each assembly line. For instance, they assign scooter tires and motorcycle tires to the bike assembly. If left unfixed, all tires will go to the wrong assembly. So we are tasked with hacking into the system and undoing the attacker's steps. So basically you can look over here, and for the bike assembly, we're, instead of using bike tires, we're using scooter tires or motorcycle tires, which is not going to work. So when we go over, we can look at the inventory and we can see the different names and the code used to identify that specific tire, and then we can go over here to our activity. Now in this scenario, we are Roddy, the warehouse supervisor, and we can look up at the top and see the employee ID is being shown to us right here. Now with everything that we just learned, what if we tried to change that and we tried user ID number 12? So there isn't a user ID number 12. We know that user ID 11 works, so maybe we could try user ID 10. And here we've got Anton, and he's also a warehouse supervisor. He has no recent activity. Let's try another one, user ID 9. And here we go, we found this person, Alia, and she is the database administrator and has changed all of the different numbers for all of the inventory, which is what messed up all the systems. So if we go in as a manager of this database and revert all of these actions, we fixed it, and we get our flag, which is THM IDOR explored. And we can just copy that over if I am able to highlight it here. There we go. And you paste that flag right in there, submit, and we have completed another room. So this was just a very, very simplified introduction of web application security, web applications that we use on a regular basis. We try to secure them the best that we can, and there are tons of different things to go into. TryHackMe gives a lot of information about web applications, and especially as you start getting into the penetration testing aspect of things, you'll understand lots and lots of vulnerabilities in web applications. So again, thank you so much for watching this video up to this point. I hope that I was able to help you out if there was any concerns that you had with this video. Do me a favor, drop a like down below, subscribe to the channel if you're not subscribed already, and anytime that you've got any concerns or questions about a TryHackMe room, come back and visit this channel. Especially in the future, we should have a lot of content on about TryHackMe, walking through all the different things that are in these rooms. And anyways, I hope this video helped you out a lot. I hope that you're able to learn something or maybe see something explained in a way that you hadn't heard it before to help you understand it better. If I did help you, leave a comment down below and let me know what I helped you with. And if there's any content that you'd like to see and me give a little bit better priority to, leave a comment down below or let me know. Thank you so much though for watching this video, and I'll see you next time.